All right, so we're going to go through cross product. So section 2.4 today. There you have your definition. Guys who do you guys who do definitions can write them down. And once we're done with things, I'll switch back over so we can talk if needed. But, all right, so here's our first example. They want us to use our definition. So we want to find P cross Q. And I should be able to write on here. Let's see if it works. So P cross Q. Hey, look at that, I'm teaching. Okay. So we're given P is -1, 2, 5. And we're going to cross that with Q, which is 4, 0, -3. Apologies for how squeezed it is there. So if we use our formula, we know that we have to do P sub 2, Q sub 2, oh, sorry, Q sub 3. Go away. Minus P sub 3, Q sub 2, comma, and then P1, Q2 minus P2, Q1. Okay. So now we're just going to plug in. You guys can do this at the same time. I'm sure you don't need me for everything. Oh. Where am I at? And then unfortunately I don't have enough space. So okay. All right. So hoping everyone knows their algebra well enough, we should get -6, 17, -8. P cross Q. All right. So do we like that approach a little bit better than just, reading through the slides very quickly? Okay. So should be able to just. Any questions on that one? All good? Cool. Right. Wonder if I can move this. I cannot. Sorry. Okay, so This is showing you that thumb rule again. I like that for you guys to have that there, so I left it. We're gonna do the next example here that says if we have vector u, which is 0, 2, 1, and vector v, which is 3, negative 1, 0, they want you to calculate u cross v and v cross u and then graph it. You can see that the graph's already done for us. I'm not going to fill out the formula each time. I'm just gonna give you guys what it should be, and then if you disagree, you can always work it out later. And then v cross u, we would end up with negative 1, negative 3, 6. Okay, so it makes a difference what they're asking for, right? So essentially finding the other distances there. All right. And then what I'll do after we go through everything, we will oh, I think that was the answer. I guess I was supposed to show you this on the other slide. Sorry. I will be able to save this as a PDF with my writings on it, and I'll post it for you. So, here are some formulas that will be helpful to you. So you'll probably want to write them down. When we talk about the vectors that we're used to talking about. I don't know what just happened there, but so when we have what are you doing? I cross j, we'll have k left. J cross k will give us I left. So k cross I will give us j. And then we also have j cross I will give us negative k. K cross j gives us negative I. And then I cross k will give us negative j. So those are going to be important to you in the sense that, like, if you see it and you recognize it, then you don't even have to do the work. You'll already know what the answer is. Okay. So you can recall that these are, so I is 1, comma 0, 0. J is 0, 1, comma 0. And K is 0, 0, 1. So then you can fill the above in as you need to. Okay. So very good tool to have. Okay. So like I was saying before, once you know what that is, so if you were doing this problem and we have I cross J cross K, then we know that this first part why can I not let you in? Um, So we know that the second part, I guess I should say, the J cross K from what we just talked about is equal to I. So it's going to be I cross I, which is just going to be 0. And you can prove that to yourself a whole bunch of times. That's why I gave them all to you. And then there's also your properties there. Okay. All right. I'm going to let you guys look at the slides later to get the other properties so that we can hopefully get both in. I think we'll be pretty good. We've only been working for like 15 minutes and we're already on slide 6 out of the first set. So the upside to these, I'm using a Jamboard, by the way, and I think they're pretty cool. Not only can I save my work as a PDF for you guys, but it doesn't go past 20 slides. So you literally can't have 120 slides if you tried. All right, so the next part is we're going to use the properties of cross product. So it says use the cross product properties to calculate 2I cross 3J cross J. So we just, and you guys can tell me if there's any color choices that I'm using. If it doesn't work for you, just let me know. And I will try to stick with those colors that you can see. Okay, so we know that this part here, I cross J, is just going to become K. So if we do our 2 times 3, which will give us 6K cross J, then you can pull and it'll be 6. And then that gives us 6 times minus I, or negative 6I. So, like I said, the homework should tell you how it wants its answers. That should be fine. I wouldn't see why it isn't. All right, and then we have theorem 2.7 there, which is the magnitude of the cross product. So if we let U, oh my goodness, my phone is like blowing up. If we let U and V be vectors and we let theta be the angle between them, then the magnitude of U cross V is equal to the magnitude of U times magnitude of V times sine theta. So I would suggest writing that portion down because we are going to turn around and use it in an example. Okay. So it says calculating the cross product, use the properties to find the magnitude of the cross product. So if we are given U is 0, 4, 0, and V is 0, 0, negative 3, we know that we have to use the magnitude. It's going to be the magnitude of U times, yeah. Times the magnitude of V sine theta. Which we apparently know to be I over 2. So we would have the square root of 0 squared plus 4 squared plus 0 squared times the magnitude of b, 0 squared plus 0 squared plus negative 3 squared. Nope, sine I over 2. Okay. And then that gives us square root of 16 times square root of 9 sine theta over 2, which is 4 times 3 times sine of theta over 2 is just 1. So our answer is 12. Okay. All right. So, as a side note, while folks are writing that down, if you were not able to get to all of your homework, I did reopen them. I felt with like the holiday being smashed in there, maybe some folks couldn't get to things. So just want to make sure that everyone has time to work on everything. If you didn't score as high as you would like and you would like to go back in, you certainly may. Definitely let me know if you have any issues with anything. Okay. So now we're going to work on determinants and the cross product. You can write this down. I think it's going to be more beneficial when you see an example. I would write this portion down. That is probably going to help you. So we will be using it in our next problem set. So since I'm giving you the formula here, I am not going to rewrite the formula on the next slide, just because I'm afraid we'll run out of space. So and I can kind of only go on the sea of faces that are currently not black, so I'm gonna assume you're okay. All right, what we are doing here then, what I'll do to try and help you guys out is we know that this is A1, A2, A3. We know this is B3 and B1. And then stop. We know this is C1, C2, C3. Okay. So let's not make this Christmas. Okay. So we're gonna pull the 2 out. 2, 1, 3, 3, 4. Notice that the second one is a negative, even though the 5 is not. That's just part of the formula. -1, -2, 3, 4. And then the next one is minus because of it would be a plus, but the 1 was negative. So just keep that in track for yourselves. And that'll be -1, -2, 1, 3. And then we will have 2 times 4 minus 9 minus 5 times -4 plus 6 minus 1 times -3 plus 2. And we have 2 minus 5 minus 5 times 2 minus 1 minus 1. And that will give us a -10 minus 10 plus 1, -20 plus 1. So that is a -19. Okay. Hopefully you can see how the discriminants were done. If you forgot about them, hopefully it jogged your memory. Right? And if you have any questions, you certainly may ask. Okay. All right. Okay. So the next thing we're going to work on is we're given U and V as basically like skeleton vectors. So it says then the cross product for U cross V is given by the following. Hmm. Okay. I understand what they're doing. So this is not a problem. This is just them. So this slide is basically saying, um, if I, J, and K are involved, okay. So it's basically telling you that you don't have to worry about all of it or writing all of it out. You're just going to use I, J, and K and then break the other vectors down as the following. Okay. So that is, it's basically a shortcut. So they're giving you a shortcut. So I would definitely write that down if you didn't think it was important. It's important to you. Okay. All right. Okay. So we're going to use what they just told us, using the determinant notation to find P cross Q. So in this is a problem I believe that has been done already. So we're just doing it from this approach. So P cross Q. All right, we know we have I, J, K. Then we have -1, 2, 5. We have 4, 0, -3. Okay. So then we're just going to pull our pieces. 2, 5, 0, negative 3, I, minus negative 1, 4, 2, 0, j, plus negative 1, 4, 2, 0, k. Okay. And then we're just going to go through and do the determinant. So negative 6 minus 0, I, minus, oops, I wrote the wrong thing down here. That should have been a 5, negative 3. I went too fast for myself. Yeah. So that gives us 3 minus 20, j, plus 0 minus 8, k. And then you just go through and finish it out. So we would have negative 6i plus 17j minus 8. Okay. And I believe if you look at example 2.31, we also found P cross Q, but that answer was in this form. So you can see that you can use either approach. Kind of just going to come down to what you guys prefer. But assuming no questions, we'll keep it moving. Okay. So finding a unit vector orthogonal to two given vectors. So if we let vector A be 5, 2, negative 1, and vector B be 0, negative 1, 4, we want to find a unit vector orthogonal to both A and B. So the first thing you have to do is you need to figure out your cross product. So we're going to take A cross B. So we would have I, J, K, 5, 2, negative 1, 0, negative 1, 4. And then we pull our pieces out. So we'll have 2, negative 1, 4, I, minus 5, 0, negative 1, 4, J, plus 5, 0, 2, negative 1, K. And then go through and work that out. We have 8 minus 1. Nope, that's a typo. It should be a plus 1. I minus 20 minus 0. J plus negative 5 minus 0. K. Which would give us 9I minus 20J minus 5. Okay. Okay. Then, what you have to do is normalize the vector so that it's in the same direction. So we have to find the magnitude. can tell you that the book answer is wrong because they did not take -1 times -1 correctly. So 9 squared is 81. That's 400 plus 25. The square root of. We're going to leave it as the square root of 506. So that means we would have 9 over the square root of 506 minus 20 over the square root of 506 and then minus 5. Is a unit vector orthogonal to A and B. I don't believe I was incorrect on that. If you think I am and you can tell me why, then, or why you think the book would be right, but if you go through it, I would believe that that was an incorrect solution on their part. All right, any questions on this one? Yes.
Yeah, so after you get the 8+1 from multiplying the two negative ones, shouldn't you still subtract the positive one there?
From the formula, yes, you are right. So that is why they had it that way. Good call. Here I am just thinking they were screwing up their signs. All right, so that changes our answer a little bit. And this is why we talk things out and we don't just assume that we know what we're doing. Nice job. Okay, so that would give us a 7 there. Which would give us a 49, which does have the 474. Oops. All right. A nice job. Any other questions other than catching me trying to catch them, not make a mistake? Cool. Okay, so area of a parallelogram, we're going to use the cross product to find it. You can see that it's right down here. So you will probably want to take note of it. It's going to be the base times the height. So we're going to use the magnitude of u and then times the magnitude of sine theta, which ends up just being the magnitude of u cross v. And we will more than likely have an example. Okay. So almost done with the first portion. Is there anything important behind there? I don't know how I do that thing where I see what's behind there. Nope, not important. Cool. All right. So if we let P be 1, 0, 0, and Q be 0, 1, 0, and R be 0, 0, 1, of the vertices, okay? So we're essentially going to find our area, which would end up being the magnitude of PQ cross PR, which would be I, J, K, and then a negative 1, 1, 0, and then a negative 1, 0, 1. Okay. And then we can start to pull stuff out. So that works out to be 1 minus 0, I minus 1 minus 0, J plus, I'll write it down below, 0 minus 1, K, which will give us I plus J plus K. That almost seemed intuitive when you read the problem. And then that's just the cross product. That's just P, Q cross P, R. Okay. So now we have to find the magnitude. So So then the area triangle PRQ, sure, however you want to label it, is half so it's going to be right. And I would assume you guys will have problems like that on your homework that you can work through. Okay. The next thing we're going to work on is triple scalar products. So you can take away from this what you want. We have an example, but it's not until slide 16. So the triple scalar product of vectors u, v, and w is u dot or u times, and then the cross product of v cross w. So they show it to you here as well. And then they also give you the proof. So if you didn't want to believe them, they then proved it for you as well. Mhm. We cool to move to the example? Yeah. All right. Okay. You will notice that I have an affinity for writing in the red. So if I think that stems back to like, remember in grade school, teachers always graded you with the red pen. I think I was like determined to take red back as like a positive color. So I like never graded red, but I always write in it. All right. So we're going to apply the triple scalar product, and U is 135, V is 2, -1, 0, and W is -3, 0, -1. So first thing we're going to do is throw it into our 3x3. So 1, 3, 5, 2, -1, 0, -3, 0, -1. All right. Then we're gonna pull our stuff out. So 1, -1, 0, 0, -1, -3, 2, -3, 0, -1, oh, and plus 5, 2, -3, 1, 0. All right. And then we would have 1 times 1 -0, -2, -0, and plus 5, 0, -3. So that would give us a 1, a +6, and a -15 for a -8. All right. I'm gonna let you guys read through and write your stuff down for here. I have to grab a drink. I beyond parched right now. So I'll be right back. Okay. Okay. So let's work this example out. So we're giving U as -1, -2, 1, B as 4, 3, 2, and W as 0, -5, -2. You'll notice that even if I didn't give you the written answers, I gave you all of the drawings. Because I would have just totally butchered that. So thought you guys would want, yeah, the clean version. So we would use our U times RV cross W. So that's going to look like -1, -2, 1, 4, 3, 2, and 0, -5, -2. Okay. And then we'll start pulling our stuff out. +2. And +1, but it's understood there. So then that gives us a -1 times -6 plus 10 plus 2 times -8 minus 0 plus -20 minus 0. We have to work this out. 2 -4 -16 -20. And that gives us a -40. That is a fun word. So, we cannot say that the volume is -40. So what we say instead is the volume of the parallel I left out an E. R A L L E L E is 40 units cubed. We'll try to make that neater. Okay. All right. You're okay. Good to go. All right. We do problems on this page because I had to make it work. All right. So using the triple scalar product, all right, so that's where we use this part. We do U times V cross W. So we'll have 2, 0, 5, 2, 2, 4, 1, -1, 3. All right. And then I'm not going to pull everything out. If you need to see it pulled out, you certainly can keep doing it that way. But since we don't have a ton of space, I'm going to skip a little bit. So we would have 2 times 2 times 3 plus 0 times 4 times 1 plus 5. I have not been signed out. All right, that was annoying. 5 times 2 minus 1. Oh, this is super long. Minus 5 times 2 times 1 plus 2 times 4 times -1 plus 0 times 2 times 3. That's going to just work out to 2 minus 2. So it is 0. Okay. So what that tells us is, so the volume is 0 units cubed. Which means one of the dimensions is 0. Therefore, the 3 vectors all lie in the same plane. Stop. So, if you guys wouldn't have been able to jump to the vectors were in the same plane, would you at least been able to go, how do we have a volume of 0? So, hopefully you all would have gotten to that. Right? Feeling pumped. Feeling like we can probably get this done, the 2 sections. All right, so the second question on this slide is saying only a single plane can pass through any set of 3 non-collinear points. Find the vector orthogonal to the plane containing the points P, Q, and R. Okay, so the first thing we have to do is figure out what PQ is and PR. So PQ is gonna be 1 minus 9, 3 minus a -3, and then 0 minus a -2. So that's gonna give us -8, 6, and 2. And then we also have QR, which will be -2 minus 1, 5 minus 3, 0 minus 0. So that will give us -3, 2, and 0. Ah, technology, I swear, is not my friend. And do anything. All right, now we're gonna do P, Q, cross Q, R. It's gonna be I, J, K, and then -8, 6, 2, -3, 2, 0. All right, and again, I don't have room to pull anything out, and I'm not gonna take the time. Like, you can work it out long ways if you need to. So then we have 0, I, sorry, 0, I, -6J, -16K, minus -18K, plus 4I plus 0J, and that's going to give us -4I -6J plus 2K. Okay. I'm just curious why we don't have to do that other part like we did before. Guess we don't. That's what they want. All right, the next one is our application problem. Okay. You guys might need to look at this closer in the book if it's too small, but it's in there for you. I just pulled it out in case you wanted to see it here. So it's saying a bolt is tightened by applying a force of 6 newtons to a 0.15 millimeter wrench. The angle between the wrench and the force vector is 40 degrees. Find the magnitude of the torque about the center of the bolt. Round the answer to 2 decimal places. So we're essentially finding the magnitude of the torque. It just looks like a fancy R to me, so I apologize if those look super similar to you. And I'm pretty sure that my power just flickered, so if I lose you guys, at least we got one of the sections done. So we're gonna pull from what we know. Make sure that you guys are using the right radians versus degrees when you work on stuff in the homework. That might trip you up on your answers. So if you plug that in, you should get all right. Cool on that. Okay. All right, so we kind of have an option here. My personal vote is that we just go ahead and do section 2.5. I don't think it's as many slides. I don't think. Yeah, it's a little bit shorter. And then my strong recommendation would be that all of you can have Thursday to work on your homework and kind of review chapter 2 by yourselves before we go into, I think next week we wrap up chapter 2 and then we start into chapter 3. And then once we're done with chapter 3, we'll be probably doing a quick review and then taking your first exam. So I kind of vote on just continuing and trying to finish it out. Is that like an okay all around? Let's just get this section done. Okay. All right, cool. Taking that as the majority. So let me save that as a PDF. And then hopefully I can just just gonna save your stuff real quick. Okay, and then let's go to the second one. So that was 2.4. We're, oh, nope, going to do 2.5 now. That's fine. You're ridiculous. Okay, so 2.5, equations of lines and planes in space. Okay, so we are given our little formula there. If we're given the vector v as ABC, and we have point P, which is x sub 0, y sub 0, z sub 0, then we know that x is equal to the following, y is equal to the following, and z. And then if the constants a, b, and c are all non-zero, then you can write the line as the following. Okay, so for the first problem, we're literally just going to shove the information into the formula. So we know that we have these 2 points on our vector. So our vector would be -3, -1, 5, -4, 0, minus, and -2, which is going to give us -4, 1, 2. All right, that's our V. And then you can use either point on the line to complete the parametric equations. So it really doesn't matter. I'm just gonna do x equals 1 minus 4t, y equals 4 plus t, and z equals -2 plus 2t. Oh my goodness, I hate when that does that to me. Oh, it's like the most annoying thing. So -2 plus 2t. Okay. And then we would just solve each equation for t to create the symmetric equation. So you get x minus 1 over -4 equals y minus 4 equals z plus 2 over 2. So that's your overall answer. You can work that out with the other point as well. Totally up to you. Right. Okay. All right. Okay. So we have some more notes on this page. So let's just kind of work on the highlights parts. So we care about this. Using the properties of vectors, then we know that this is the same as this, which is the same as this. Oops. And we care about this one. And we care about this one. And this is probably where I'm saying, like, if you guys could pre-take your notes, then we can just hammer out examples and be good to go. All right. Parametric equations of a line segment. So find the parametric equations of the line segment between points P, which is 2, 1, 4, and Q, which is 3, negative 1, 3. Okay, so if we work them separately, first let's write out what we're going to work at. So our goal is going to be x equals x sub 0 plus t x sub 1 minus x sub 0. Then you have y equals y sub 0 plus t times y sub 1 minus y sub 0. And then z is equal to z sub 0 plus t z sub 1 minus z sub 0. And then 0, t has to be greater than 0, but cannot be less than or equal to 1. Okay. All right, working with each component separately, we get the following. So I'm just going to go straight down each one. That seems like the easiest thing, in my opinion, to do. So we would get x is equal to 2 plus t times 3 minus 2. So x is equal to 2 plus t. Then y is equal to 1 plus t times negative 1 minus 1. So y is equal to 1 plus, nope, minus 2t. And then z is equal to 4 plus t, 3 minus 4. So z is equal to 4 minus t. Okay. We didn't even need all that room. Therefore, x equals 2t, 2 plus t. Y is equal to 1 minus 2t, and z is equal to 4 minus t, given that the parameters for t. And that's all they're looking for there. All right. Okay. So the next part we're looking at, so I have a little diagram there for you, and I have the distance from a point to a line for you. So it says calculating the distance from a point to a line. If we find the distance between key at point M and the line, and you have the given information, then I think that is supposed to be something. I don't think that's supposed to just be okay. So from the symmetric equations of the line, we know that the vector v would be 4, 2, 1. Is a direction vector for the line. Setting the symmetric equations of the line equal to 0, then we're going to see that the point is 3, -1, 3. Okay. So then if we're looking for PM, then we would end up with 1 minus 3, 1 minus a -1, and then 3 minus 3, which will be -2, 2, and 0. Then we have to calculate the cross product. It's going to be I, K, K. And then we know it's -2, 2, 0, and 4, 2, 1. All right, and then we're going to pull stuff out. I'm going to try to squeeze it because we got one more thing going on after this. So we're going to end up with 2 minus 0, I, minus -2 minus 0, J, plus -4 minus 8, K. So that gives us 2I plus 2J minus 12K. All right. So we do all that. And then the distance, then we're now gonna use this formula with all that information that we just found. So I'm not gonna rewrite the formula, it's right over there for you. So I'm gonna try to save us room and go straight into it. So 2 squared plus 2 squared plus 12 squared over the magnitude of v, which is 4 squared plus 2 squared plus 1 squared. And that is going to be 4 plus 4 plus 144. Square root of 152, which is going to be 2 square root of 38. Over the square root of 21. So if you guys work through your homework just using the formulas and stuff, you should be okay on the majority of this stuff. Right? Okay, so relationship between lines. I just threw this in here. The textbook had it. So I assume it's kind of important, I guess. So lines share a common point if it's yes, then direction vectors are parallel. It'll be, and also, yes, then they're equal. If they do not share a common point, and they are not parallel, then they are parallel but not equal, and they are parallel. If they do not share a common point and they are not parallel, then they are intersecting. And if they do not share a point and they are not parallel, then they're skew. If they share a common point and they are not parallel, then they're intersecting. Okay? That's just, I guess, to give you more of an idea of like visually what's going on with some stuff. That was always harder for me. Okay. Slide 6. All right. Part A. All right, so we're gonna have the same problem for the next 3 slides. This one, I'm just gonna have your answer to part A on it. So we're just dealing with this one. So line 1 has the direction vector 1, which is 2, 1, 1. Line 2 has a direction vector of 1, 3, -2. Because the direction vectors are not parallel vectors, the lines are either intersecting or skew. To determine whether the lines intersect, we see if the point XYZ that lies on both lines. To find this point, we use the parametric equations to create a system of equations. So we would have, using everything we just went over, we would have 2s minus 1 equals t minus 3. And then we would have s minus 1 equal to 3t plus 8. And then we would have s minus 4 equals 5 minus 2t. So if we look at the first equation, t equals 2s plus 2. And if we substitute that into the second equation, so into here, s minus 1 equal to 3, 2s plus 2 plus 8. And we work that out, we'll end up with 5s. This is an s. Oops. Skipped a line anyway. S minus 1 equal to 6s plus 6 plus 8. That's going to be 5s equal to minus 15. So s equals -3. And then if we shove that into the third equation, we then would get, so we don't want to shove that into the third equation. We want to compare s minus 4 by minus 2 times 2s plus 2. We get s minus 4 equals 5 minus 4s minus 4. So then we get 5s again equal to 5. So s equal to 1. Okay. So since the s's don't match, we have a contradiction. Okay. All right. That is all just for part A. Okay. I'm going to do part B now. I'm doing this one. All right, so again, we have vector 1 from line 1 is 1, -1, 1. Vector 2 from line 2 is 2, 1, 1. And it's actually passing through the origin, which is equal to 0, 0, 0. Okay. So then if we check out what we're given, then we know that so the lines are not parallel or equal, so we're gonna let R equal the parameter for line 1, parameter and we're gonna let S be the parameter for L2. Okay. So that being said, we then would have X equals R, Y equals -R, and Z equals R. And then we would have X equals 2S plus 3. We would have Y equals S and Z equals S plus 2. Okay, so when you solve that system of equations, you end up getting that solve system. You end up finding that R is equal to 1 and S is equal to -1. And then if you need to, you can substitute and you'll actually find that this means there is an intersection at 1, -1, 1. Okay. And I think I skipped C. It's in here, but I skipped it. So you guys can try to figure it out. Right. I'm just trying to make sure that we have enough time for everything we should. Okay. All right, so we have a couple slides of notes. Let's see. So equations for a plane. We say that n is a normal vector, or when perpendicular to the plane. Remember that the dot product of orthogonal vectors is 0. This fact generates the vector equation of a plane. Rewriting the equation provides additional ways to describe the plane. So this is what you're interested in right here. And we're going to get to a we're going to get to an example. Cool. Okay. So here's some definition for you. Kind of basically sums that other part up a little bit better. So we're gonna have given a point P and a vector n, the set of all points Q satisfying the equation n dot PQ equals 0 is known as the vector equation of a plane. The scalar equation of a plane containing point P is given as follows. Okay, so if you didn't write those down, you should. The equation can be expressed as the following. This form of the equation is called the general form of the equation of a plane. So I recall back in the day when taking paper tests, that probably would have been a bonus question to write this part down. But we'll see. I don't know if I'll do any bonus. Give a lot of points anyway, so all right. We cool to try out an example. All right. All right, we're flying. Okay, write an equation of a plane given 3 points in the plane. Okay, in both standard and general forms. Lovely. I really hate when they make you do both forms of stuff. Okay, so, and remember your homework will always tell you what it wants. You don't have to guess, it just tells you right away. So we have to find PQ first. So that's going to be 0 minus 1. And then 2 minus 1. And 1 minus a negative 2. So that gives us PQ as negative 1, 1, 3. And then we also have to find QR. So that's 1 minus 0, negative 1, minus 2, and 0 minus 1. So that's going to be negative 1, negative 3, negative 1. Okay, so we're going to use those to help us out. So the cross product PQ cross QR is orthogonal to both PQ and QR. So it is normal to the plane that contains the two vectors. So in other words, we're going to have n equal to PQ cross QR. So we're going to have I, J, K, negative 1, 1, 3, negative 1, negative 3, negative 1. And if we go through and pull everything out, you would have negative 1 plus 9 I minus 1 plus 3 J plus 3 plus 1 K, which would give us 8 I minus 4 J plus 4 K. That would be the first part. So that, therefore, or thus they say, n. It's really hard to do an n as a vector. N equals 8 minus 4, 4. I'm dying, guys. And we can choose any of the 3 points to write the equation in the plane. So you can use P, Q, or R. I believe we are using P, I think is what they're using. So 8 x minus 1 minus 4 y minus 1 plus 4 z plus 2 equals 0. So then you would get 8x minus 4y plus 4z plus 4 equals 0. So there's both your forms. Okay. All right. So writing an equation for a plane given a point and a line. Okay, they have their little drawing, which you guys should definitely get in the habit of drawing. All right, so here's our solution. The symmetric equations describe the line that passes through the point 0, 1, negative 1. Parallel to the vector v1, which is 1, 2, 1. Check out the figure. So we're going to use the point and the given point, 1, 4, 3, to identify a second vector parallel to the plane. So given all this information, we have a vector 1, which is 1, 2, 1. And we have a point 0, 1, negative 1. So we need to use the 2 points to find vector 2, which is going to be 1 minus 0, 4 minus 1, and 3 minus a negative 1. So that's going to give us 1, 3, 4. Use the cross product of these vectors to identify a normal vector for the plane. So, goodness. V1 cross V2. We're going to have I, J, K, 1, 2, 1, 1, 3, 4. We're going to pull everything out, and we're going to end up with 8 minus 3i minus 4 minus 1j plus 3 minus 2k. That gives us 5i minus 3j plus k. Alright, so that's that part. And then, so the scalar equations for the plane would be 5x minus 3y minus 1 plus z plus 1 equals 0. And 5x minus 3y plus z plus 4 equals 0. Okay. All right. Okay. Nearly done. All right. So this is what you care about on this page. The distance between a plane and a point. All right. You need to find the magnitude of the projection of QP onto N is going to be equal to the magnitude or the absolute value of, what does that one mean? It's there for you. I have to deep dive on what that word means. All right, only a handful or less, more examples, and then we're good to go. Okay, so find the distance between point P and the plane given by x minus 2y plus z equals 5. So they give you the figure below. So the coefficients of the plane's equation provide a normal vector for the plane. So the n is given basically to us as 1, -2, 1. To find vector QP, we need a point in the plane. Any point will work. So we can set y equal to z equal to 0. So that would give us Q as 5, 5, 0, 0. Find the component of the vector form from Q to P. So we would have 3 minus 5, 1 minus 0, 2 minus 0. So that's going to give us -2, 1, 2. And then apply the distance formula. Say distance. I'll write it down. Times n over the magnitude of n. And we have 2, -2, 1, 2. Times 1, -2, 1 over 1 squared plus -2 squared plus 1 squared. And that gives us the absolute value, -2 minus 2 plus 2 over the square root of 6. So we end up with 2 over the square root of 6. Now, technically, algebra would tell you that you really would need to do that, but this is what they have. So guess we'll leave it the way they want it. But alrighty. I'm sure you guys will have a better handle on everything once you go through your homework. Spend some time with this stuff. All right, so finding the line of intersection for two planes. Find the panoramic and symmetric equations for the line formed by the intersection of the planes given by the following. Okay, so the first thing we have to note is that the planes have non-parallel normals. So in other words, the planes intersect. Further, the origin satisfies each equation, so we know the line of intersection passes through the origin. Add the plane equations so we can eliminate one of the variables, in this case, y. So we would have x plus y plus z equals 0, and 2x minus y plus z equals 0. We're going to add everything. The y's cancel. We get 3x plus 2z equals 0. So this gives us x equal to negative 2/3 z. And then if we substitute that into the first equation, we'll get 2/3 z plus y plus z equals 0. And so then we have y plus 1/3 z equals 0. So now we have y in terms of z as well. So if we plug both those into, I guess either equation is fine. Now we have two variables, x, y in terms of z, and now we find z in terms of t. So now we have to define z in terms of t. So we choose to define the parameter t as t equal to negative 1/3 z. So if we do that, then we can write the following. We would have x equals 2t, y equals t, and z equals negative 3t for your panoramic. Okay, so that's your first part. And then your second one is a little bit nicer. You would end up with x over 2, y, z over negative 3. We only have 2 more examples left. We have another example and then a small slide of notes and then the last example, and then we should be good. So I'll be good. Okay, so determine whether each pair of planes are parallel, orthogonal, or neither. If the planes are intersecting but not orthogonal, find the measure of the angle between them. Give the answer in radians and round to 2 decimal places. So the first one, they are actually scalar multiples of each other. So the normal vectors are parallel, and so then the lines are parallel. Because scalar multiple. Okay. So for B, we need to take the dot product of 2, -3, 2, dot with 6, 2, -3. And we have to see if that's going to, what that's going to be. So when we work this out, you'll get 2 times 6 minus 3 times 2 plus 2 times -3. And you see that that zeroes out. So since it zeroes out, they're orthogonal, so the corresponding planes are also orthogonal. Orthogonal. Okay, so that's for B. All right, so C, we have normal vectors as 1, 1, 1. That's coming from here. And then you'll have your n sub 2 will be 1, -3, 5. Okay. So we're going to do cosine theta. And you can look up the formulas if you need to. Just trying to save us some time. Okay, so that works out to be 3 over the radical 105. So the angle, or theta, between the two planes is 1.27 radians, or approximately 73 degrees. Okay. And again, when you're going over these, if you go over these again while you're doing stuff, you can pause it as you need to. Obviously, there was some hiccups in between with stuff, so I apologize on that. I'll try to get this uploaded for you guys tonight and make sure that I uploaded the last one. I think I uploaded the notes, but not the video. All right, so this is your distance formula, and then we're going to do one example with it, and you guys are good. So the distance from point A to a plane, from a point to a plane. So we have P given as x sub 0, y sub 0, z sub 0 to be the point, the distance from point P to a plane, and it's given to you as the equation. You take the absolute value on top divided by the square root on the bottom. So I guess because I'll save the PDF for you guys. All right, so our point is 1, 0, 0. Okay. And it lies in the first plane. So the distance then is absolute value of a x sub 0 plus b y sub 0 plus c z sub 0 plus k over the square root of a squared plus b squared plus c squared. So that is going to give us the absolute value of 2 times 1 plus 1 times 0 plus -1 times 0 plus -8 over 2 squared plus 1 squared plus -1 squared. And that is going to give us 6 over the square root of 6, which just works out to be the square root of 6. So that time they did rationalize it. Okay. I'm going to end the recording. Why is this not doing what I want to do?